All right, cool. All right, welcome back, everybody. The next talk will have Ahmed, and let me just show his screen as well, so you can see the title of the slide. So Ahmed, if you want to switch that to a full screen, that will be great. Okay. And then I will click on Add to Stream. All right then, take it away.
Cool. Hi, my name is Ahmed El-Helw. I'm an Android engineer at Careem, and I want to talk to you about our experience building a super app or merging multiple apps into one. For those who don't know, Careem is a ride-hailing company that was acquired by Uber last year. And the way things started is we started off with a set of apps. We started off with a ride-hailing app that was our primary app with the vast majority of our user base. And after that, we got into food deliveries and groceries and so on and so forth. And each one of these had its own separate app. And the idea was to combine all of these together into a single app, a super app, essentially. And it would look something like this. And this is actually a screenshot from the production version of our app, where you can see at the top there's a set of production tiles available, services that are available. And for example, if I click on the car tile, I'll get the ride-hailing experience where I can go and book a ride. Or if I click on the food tile, I get the food experience where I can order some food. Now, you might notice that these two apps don't look very as if they're part of the same app, and that's because they were two separate apps. And we'll talk a little bit about the challenges of some of this and like how we're actually working on kind of combining the UI of these as time moves on in the future. So why talk about this? Not everybody's building a super app, so why give a talk about this? First, I find it to be an interesting way to look at Android development and architecture. And gives us kind of a new way to think about the collaboration between multiple teams, multiple Android teams in a company. I think smaller teams can also use it as a kind of an outlook into how a potential future can be like, and can kind of try to start planning now for unexpected changes. Like we never knew we'd have to build a super app. And if we had known earlier, there were a lot of things that I wish we had done differently before having to build one. And it's fun. So, okay, and just a brief note about the world before. Before we built the super app, the company had several silos, right? Like every Android team was its own silo, focusing on their own development. So the ride-hailing team was one silo, focused just heads down working on the ride-hailing app, and so on and so forth for the food app and for the other apps. And essentially, there was very little sharing between the projects, not too many common libraries that we had. There was no platform team to kind of help identify things that were being repeated and kind of correct them or anything like that. And we did have a bi-weekly sort of coffee meeting where we could share ideas and things. But as time went on and people got more and more busy, it slowly kind of died down. So, okay, great. So how would we go about doing this? So if you think about if you think about it, we already have apps in production, right? So the idea was the ride-hailing app is our largest app and has the largest user base. So by taking the application ID of the largest app and building from there, that's something we wanted to do, right? Because we don't want to have to reacquire people again to use the app, customers again, by actually shipping a whole brand new app with a new app ID. And the individual apps can continue shipping their standalone apps until either the business decides to remove them or it seems like a good time and so on and so forth. So to do this, essentially, we have two options, right? There are two different approaches we can take. The first is we can try to convert the ride-hailing app directly into the super app. And what I mean by that is that we say, okay, we have a working ride-hailing app. Let's just add maybe a button somewhere for the food app and just kind of connect it to launch the food app somehow, right? Pros of this are it's easier to begin with. We just need to figure out how we add these other apps. But on the downside, we don't have a separation of concerns. And if you think about it, like how do you draw the line between what code belongs to ride-hailing, in this case, versus what code belongs to the food app, or versus what code belongs as a part of the platform that belongs to both of them? So you don't really have a concept of platform code in this case. And if you wanted to keep the existing app in the store in the meanwhile, like the existing food app, for example, we wanted to keep it in the store in the meanwhile until we actually decided to remove it. As time goes on, it would continue to diverge from the actual SuperApp version of it, which is not ideal for the developers to kind of maintain. So the second option is we create a brand new app. So think about a brand new Git repository kind of thing. And we change the app ID to be the app ID of our largest app, the ride-hailing app, and figure out a way to be able to use ride-hailing from this brand new repo that has nothing in it at all. And we would repeat this for everything else so that our Git repository for this new app is essentially a shell repository now with mini apps inside it. And the pros of this approach are it's cleaner and kind of more correct over time. And you can kind of converge the SuperApp implementation of each vertical or each mini app with the actual standalone versions. We'll talk about that in a bit. But some of the downsides is there's more upfront cost to doing this. But essentially, the second option is what we decided to go with. So in order to do this, like how would we be able to use our largest app from this new app? So essentially what we're talking about is we want to librarize, which is not really a word, but we want to librarize the app module of our ride-hailing app. And so even stepping back a bit, how is our app module any different from any random library module? So essentially it boils down to two things, right? First, the plugin, com.android.library versus com.android.application, and Gradle configurations that are relevant to building an actual app as opposed to building a library. So ignore kind of this, but the idea is the one on the right is actually a feature module, and everything in gray is common with what's on the left, which is an app module. So what I'm trying to say is everything in library modules is already in app modules. It's just everything else is extra stuff for configuring the actual app. Another way to look at it is essentially what we have today is we have our app module, which ships an APK that we upload to Google Play or whatnot. That depends on a set of AARs and jars, both our own internal ones and external third-party dependencies. And what we actually want to do is we want to switch that app module to be a library module instead. And instead of outputting an APK, we want it to output an AAR. And when we do that, then we can actually have our standalone app, which generates its own APK depending on this library, and generate the APK that way. Or at the same, since it's a library now, I can actually depend on it from multiple places. So I can also depend on it from the SuperApp container. What I'll call these as container, this top level as containers now. But essentially, I can now reference this library from within the SuperApp container. So okay, so we want to go ahead and do this. So we can change the app to be a com.android.library instead of application. We create a new container Gradle module that will actually be responsible for being a COM Android application and for actually building the APK that will be shipped. And it depends on app. And we move whatever relevant code that we need that no longer makes sense inside of the app module into the container module at this point. And we could, if we wanted to, just rename at this point app to lib just to make things a little bit less confusing, right? So we run it and we make sure everything is good. Everything should be good because we didn't really do anything except add a level of indirection, right? Instead of directly publishing an APK from the app module, we're actually publishing that APK from a module that depends on the app module. So everything should be good. We publish these artifacts to company Maven. We tried from the new repo and it also works. But again, like that shouldn't be very surprising at this point because we just added a level of indirection. So great. Now we can probably just repeat the same thing for the food app and we're good, right? So the idea being that the picture would look something like this. The SuperApp container, this new Git repository that we created, depends on the ride-hailing library, which used to be an app, but we converted it into a library. Same thing with food, same thing with others. So we do the same thing for food. We convert food to also their app modules to also output an AAR. We give them their own container module as well so that they can continue building their standalone app. And we publish their libraries. And then we update our super app to be a 2 mini app super app, essentially. We make sure app depends on both these dependencies, ride hailing and food. And we make a simple 2-button launcher activity just to kind of test things out and make sure things are working initially. And things don't work. And some of the initial complications we run into. So first and foremost, Android manifest conflicts. So it turns out that because the ride-hailing app is much, much older than the food app, the MinSDK version on that was MinSDK 16. Whereas on the food app, being newer, it was targeting 21 and above. So that was the first kind of problem we ran into. Another was like conflicts in things like file providers, right? So the Android X file providers are declared being used both by food and by ride-hailing, and so there's a conflict there. And then the application subclass. Food says I have my own application, and ride-hailing says I have my own application. And so the manifest merger doesn't know which application to actually place in the manifest. Those are the ones that kind of like the manifest merger will actually tell you. But then you can also see there are some silent manifest conflicts just by looking at the manifest once it's yelled at you enough times. The launch activity, for example. So if we don't change the launch activity, we'll end up with 2 icons on the screen, which is probably not what we actually want, right? API keys. Which API key will be used when 2 different ones are declared? We don't know. The application theme. And okay, if we're going to remove the application or move it, what happens to the theme? And what are the side effects of whatever change we decide to do for the theme? And finally, things like analytics and so on and so forth. So a bunch of these are like things where, by looking at the manifest, you can see that these are kind of either problems that will happen or will cause at least some confusion as time goes on. And push notifications is another one. But let's back up a step and kind of think about how we can kind of get through some of this. So first off, because the SuperApp will be the shipping app, we can kind of resolve some of these up front. So we can say, for example, MinSDK will be the SuperApp's responsibility. So for the time being, let's use the lower MinSDK and gate the mini apps that require MinSDK 21 to only run them on MinSDK 21 until we're ready and can drop MinSDK 21, which actually just happened this week. So really happy about that. The SuperApp should own the application subclass. So it doesn't make sense to say ride-hailing, hey, you can have the application subclass, because then the food app it won't be able to, also wants an application subclass, right? So you can't play favorites in this case, right? And similarly for other shared components, they have to be owned by the SuperApp itself. And then anytime we run into these conflicts, so things that actually cause conflicts, a lot of times the right thing to do is not to remove them all out, but actually to move them into the container of the standalone app. Because chances are this is code that will either need to be provided, that has to be provided by the container for the app to function. So, and we'll see a little bit, I know that might be, I didn't maybe articulate that very well, but maybe it'll, hopefully I'll clarify it a bit. So okay, we tinker with the manifest just to kind of get it compiling, right? Because there's this like, once you get it compiling, you're like, okay, there's hope, right? So I'm looking for that hope right now. So we tinker with the manifest and hey, it compiles, but it instant crashes. So so how come? So let's back up a second and talk again about the application subclass. The application subclass kind of contains kind of 2 types of logic. Essentially, first is kind of initialization logic. So things where we're initializing crash reporting or analytics or critical functionality to our app. And then there are the long-living singletons, for example, like holding the graph of the DI graph, right? To the DI graph, sorry. So essentially, we say it boils down to critical initialization logic and long-living long-living objects that will live through the lifetime of the app. And we see a lot of things similar to this or flavors of this where we get the application context and we cast it to an application, and then we get the component and we kind of inject it, right? So if the application of both food and ride-hail have this, how do we actually? We can't just say like we're not going to run this logic, right? Like how do we deal with that? So we can move the initialization logic into a separate initializer class that we say, hey, initialization lives here. And we can kind of replace these fields that were long living inside of the application class to be singletons within singleton classes. And we make the container responsible for actually doing the calling of the initializers in this case to make sure that each mini app is initialized. So it can look something like this, where we created a ride-hailing initializer, just a Kotlin object, and we just say we have an initialize, we call initialize as usual, and we set our application component to whatever our tree becomes. But if you think about that, that's kind of not nice from the user perspective. From the developer perspective, when they come to actually need the application component, they'll have to say ride-hail app initializer.application component. So we can kind of actually just create an injector class, for example, and then just kind of set our reference on the injector class. And then we can just say, hey, injector.application component.inject this. So, okay, so now that we've done that, we can create an application subclass for the SuperApp, and we say, in the onCreate, we say, okay, ride-hailing app initialize this. And so now we've called ride-hailing's initializer logic. And then we do the same thing for food, and we add its initializer logic here. And then we're kind of like, that doesn't look very nice. I don't really like that. But it's a start, right? Okay, so the existing application subclasses should be migrated, in this case, to the containers in their respective repositories. So remember, early on, we created this container module to actually be able to build the repository as we used to, where it just depends on the library, the former app module. So the application subclass would move into that container because the application is a responsibility of the container at this point in time. And because you move the application to the container, that means all UI tests also have to move to the container as well, because you don't have the application subclass otherwise. So, okay, great, compile and run, and hey, it works. Well, kind of. So then here we start running into some kind of interesting issues. Here's one of them. So ride-hailing had a splash screen where the details aren't really important, but I guess the important thing is there's an image view, let's say, with an ID of splash_logo. And the food app also has a splash screen. It has a different image view, logo image view, and a progress bar and some other stuff. So ride-hailing has named its activity_splash. So r.layout.activity_splash. Food also named its r.layout.activity_splash. And SuperApp gets activity_splash. Which one? We don't know. It just picks one, right? And that's why actually AppCompat and material design library and so on will actually prefix resources to kind of avoid developers from running into this problem. So you notice like ABC_ or MTRL_, and they do this to kind of avoid, because it's very unlikely that in your own widgets you'll name something MTRL_. This kind of clash can happen with any sort of resource, layouts, strings, dimensions, themes. So think about, the default name of an app is app_name, right? So imagine that I pull in library 1 that has a string for app_name and library 2 with a string for app_name. And I declare my own app_name inside of the SuperApp container. Which one do I get? I don't know what the app name will end up being, right? So we have to kind of do prefixing to kind of avoid these kind of problems. Another thing, database names need to be unique. Now that we're living in one single app, if before, food was calling its database, and ride-hailing was also calling it database, then we're going to have problems, especially due to upgrades and so on and so forth. Like things just won't work properly. Shared preference is another example, especially default shared preferences, which is the same actual XML file. So imagine someone has a key called ID, for example, and has it as an int, and someone else has that same ID as a string. You can kind of imagine the kind of like nightmarish issues that can happen with this. Another set of problems you run into is library versioning. So given 2 versions of the same artifact, Gradle will pick the latest one. This is generally okay and generally what we want, actually. But sometimes it's problematic. So one example of this is OKHTTP and Retrofit drop support for the older versions of Android, and as of a particular version, right? And so if you exceed 3.13 point something, that's MinSDK 21 plus. And at the time, we still weren't MinSDK 21, so that's very dangerous because everything would compile and everything would look fine, but it would insta-crash on any devices before that. Another example is breaking API changes. So an API, some third-party library updates and says, hey, you need to make this change for things to work. And if one mini app were to update it, and the rest of them were not to update it, then basically all of these others would crash because they didn't actually take into account these changes. And one example of this is the material design library when it went from 1.0 to 1.1. There were some changes that needed to be made as to the default theme that's used, as to the theme that's used, right? And so if you didn't make these changes, it would compile, but it would crash at runtime. So how do we solve these problems? We use the build order manifest. So this is a feature that helps us kind of control dependencies from a single place and kind of avoid any surprises, because we kind of say, hey, these are kind of the restrictions on the dependencies that we have. So here's an example of our actual build order manifest that we're using. So it's just a dependencies block, just like your normal dependencies in your build scripts. And there's a constraints block under that where we specify the version numbers of, OKHTTP, for example, must be strictly 3.12.10, and Lottie must be 2.8.0. And if someone uses this platform, and it uses the Java Platform plugin, by the way, is how that's handled. And also, I should point out that the way this is done here specifically, if I don't depend on Lottie nor OKHTTP, this won't pull either of them into my code. This is only saying if they're present, these are kind of the boundaries to draw. But this plugin also has an option to say, hey, everyone should depend on OKHTTP this version, whether or not they are depending on it today. From the usage side, you have this block inside your own dependencies block where you say API platform, and you point to this platform artifact that you published containing these kind of rules and limits. And if you notice here, I drop the version on OKHTTP and I drop the version on Lottie because it will pick them up automatically from the platform, from the actual platform dependency. And if I were to actually go in and manually change OKHTTP to a higher version, I would actually get a compile time. It would break at compile time. So okay, great. Now what? We've tamed our dependencies. We've taken a look at whatever conflicting resources are there, and we've kind of helped to rename these. What are some of the other things that we need to do? So let's ask a set of questions, right? Does initializing every mini app on start make sense? Especially when we're always trying to optimize the application start time. And speaking of initialization, why would every mini app come in and initialize, say, Firebase or the experimentation framework or analytics providers? If everybody's using Firebase, why initialize Firebase multiple times or Crashlytics multiple times, and so on and so forth? And how will push notifications work? If everyone is just registering to receive pushes, what actually will happen? Who will actually be allowed to handle a push in this case? And how do we handle things like deep linking? So before going into these, let's take a detour and talk about two sets of libraries to kind of think about how to approach these problems. So I'll go back to the example of the Meh example, where we're calling ride-hailing app initializer and food initializer. And one of the things that stands out here is, like, why not just have some sort of initializer interface? And fair enough. So let's start by creating a mini app library. And we say, hey, this library is a set of interfaces, constants, sealed classes, enums, no actual implementation, but just a set of interfaces, essentially, that each and every mini app can depend on. So the app folder that we converted into a library from each of ride-hailing, now, and so on and so forth, food, and so on and so forth, can depend on. And inside this library, we can add our initializer interface, which can just be a simple interface with a single method called initialize with a context. And the nice thing about this method is this interface is, despite it being super simple, because it's just an initialize method, we can actually do more complicated things with it. So for example, I can create a list initializer, which just takes a list of them, and for each one just calls initialize on it, for example. And similarly, I can create a one-time initializer that makes sure that if it's called multiple times, that it only initializes once. I can do an async initializer, and so on and so forth. So great. Now we have this initializer concept, and we've made our ride-hailing mini app and our food mini app change their initialization to implement this interface. So then in the SuperApp side, we can just kind of say, I'm injecting a list initializer somewhere that I'll tell it where to get the ride-hailing initializer and the food initializer. I can set up my dependency injection, and then I can say list initializer.initialize this, and that's it. So this is much cleaner than what we had before, but it's still slow, right? Because why, again, do we start both of these on startup? So the other thing you might think of is like, well, how do I know which initializer belongs to which mini app, right? Like at this point, I have to kind of say ride-hailing. I have to actually point to ride-hailing initializer or food initializer. Like we need some sort of concept of a mini app interface that actually can hold all the logic, all the interface that a mini app should correspond to or should respect, for example. So something like, give me your initializer if you have one, right? So we'll create an interface called just for the mini app, and we'll say, hey, give me an initializer if you have one. And then when we have that, then okay, great. Now we have our same exact app class, but we no longer need to actually initialize each mini app. But we did replace our injection, instead of being a list initializer, to be a list of mini apps. And at this point, if I tap on the ride-hailing one, I can find the correct one in the list and initialize that one as necessary. And we'll come back to that shortly. Thinking about some other problems, for example, we talked about how analytics would be initialized by every single mini app, and that's kind of wasteful and also problematic, because especially think about a case where you're using different API keys. Which dashboard did your analytics end up going to, right? So we back up and say SuperApp should own the analytics and provide an interface for each of these verticals to use, or each of these mini apps to use. And with the ideal goal in mind being that eventually, no mini app should care what third-party service we're using. Like it should just say, hey, I have an event and this is a business event, log it. Or I have an event and this is a developer event, and log it. And you can think about why this is really powerful, because tomorrow business requirements change and we need to get a new vendor and we need to use that for analytics, or we need to remove this particular vendor, and this becomes suddenly very, very easy. We don't have to change things everywhere. So great, we can make our own analytics agent interface with a set user attribute, and a log event, right? Something like this. Now, okay, we have this. How do we actually give this to the mini apps? And so that's when a third interface comes into play, a mini app factory. So think about this as just, we have an interface with our dependencies, in this case, only our analytics provider so far. And we just have a mini app factory with a single method that says, given a set of dependencies, create a mini app. And in this case, creating a mini app is very lightweight, as in we're just creating the mini app object. We're not actually doing any of the initialization logic. That still is behind the provide initializer method that we saw a few slides back. But this just gives us a way to pass in these dependencies from the container, whether it's SuperApp or the standalone container, into each and every one of the mini apps in the verticals. So this container library that we're talking about So given this, okay, we talked about the container providing the actual dependencies. How does the container provide these actual dependencies? So this is where we come to our second library, the container library. And this library is part of the SuperApp itself, but we expose these libraries to Maven so that the containers of the ride-hailing app and the food app and so on can actually depend on our container as well to get a lot of this business logic. So it depends on the first library with all the interfaces, the mini app library, and it provides implementations of these libraries. So a lot of these were just interfaces. Now here's where the actual concrete implementations will live. It'll declare its own initializers where it makes sense. So for its own initialization of analytics and Crashlytics and crash reporters and so on and so forth. And it'll have a base application subclass so that each mini app can base its application on that base application and get pretty much all the functionality of initialization of analytics and so on and so forth for free. And that both works in their standalone app and it works in the SuperApp context, because essentially the code is shared in both cases. So one example of this, for example, like we can have a Crashlytics initializer, or probably should be Firebase Crashlytics initializer at this point. But okay, we have a set of other initializers like this, and then we create our own base SuperApp class. And I'm highlighting here the fact that we're depending on an interface called mini app provider, which will give the list all of the mini apps as a map, from, say, mapping between some sort of either sealed class or enum of mini app type to the actual mini app object, right? So we'll inject that in, we'll set up our dependency injection, and then we'll go through initializers that are critical app-level initializers. Things like Crashlytics need to be initialized for everyone, even if a person didn't click on a ride-hailing or on a food feature, and we'll initialize these, and that's it. And then when I click on, for example, the ride-hailing tile, I can then do something like I can cast the application to as a mini app provider, and if it is, I can say, give me your mini apps, give me the ride-hailing mini app, and then kind of give me the initializer for it and initialize it with the app context. And at this point, whether we are inside of the SuperApp or inside of one of the containers, it becomes possible to actually get a particular mini app and kind of initialize it at that point, right? The implications of this are that mini apps can test on their own, and they're testing code that's almost identical to what we have. And I say almost because they can choose to add things inside of their application subclass that we don't have if they choose to, right? But essentially, they just need to depend on the container library. And the other kind of neat thing is, because we don't actually explicitly depend on, say, on ride-hailing everywhere or on food everywhere, we can just create a no-op stub package that actually has nothing in it. And we can ship a version of the SuperApp with no food app, or with no ride-hailing app, or with neither, or with both. And we can just kind of replace these, or just say replace them at development time so we don't pay the cost of compilation, and so on and so forth. So, okay, we have these two libraries now. As you can imagine, we'll have to be constantly changing them as time goes on. Sorry. So let's say, for example, we want to support push notifications, right? And let's say we've agreed with the backend. The backend will send us app_ID field somewhere that we can use for routing to know which mini app should actually handle this particular push notification. So, okay, great. We create our own Firebase messaging service subclass, and we figure out what message type it is. And we say, give me the set of mini apps and find the first one who has a push notification app ID of this particular ID. And then we say, whatever that mini app is, if it exists, give me its push recipient, and I'll come back to that in just a second, and call on message received on it. So provide push recipient. That doesn't exist yet, right? And we want to add it. So let's add it. So it belongs probably in our mini app interface alongside our initializer. And we say, you know what, we're going to provide a push recipient, and until the mini apps can depend on this new version of the library, we're going to return null by default so that we make sure that things continue to work. But actually, if we were to actually do this and try to run it, we'd actually get a crash saying provide push recipient method is not there when we actually tried to call it. And so how come? So this happens because of binary compatibility issues. And in order to understand this, let's back up a step and think about, what do we actually get from Maven? Well, there are two types of artifacts we get from Maven, right? We get jar files, and we get AARs. But looking at a jar file, and yes, I am looking at this in Vim. Don't judge me. There are, you can see it's just a bunch of class files. So this is already precompiled code, actually. So the jar file we're getting has the precompiled code. And if we look at an AAR similarly, we'll see that there are a bunch of resources. There's an r.text, a manifest.xml, and there's again a classes.jar, which again contains compiled code. So essentially, the issue that's happening here is that we're compiling against version 1 of the library, which doesn't have this method. I didn't know that there's a method with the default implementation returning null in this case. And at runtime, we're using a different version. So as far as things are concerned, when it comes to run it, it doesn't actually know what this method is because it was already compiled. The library dependency we depended on was already compiled against the previous version. And so this method, despite being there, is actually not, we can't actually call it without doing anything, right? So at this point, we have one of two options. And of course, this only occurs if these versions are not backward compatible. So if they are backward compatible, this is not a problem, right? Like if we were to actually change implementation details, that would probably be fine, right? But in this case, this was not a backward compatible change. So how do we work around this? So there are two possible solutions to this. The first is to go to every one of the mini apps and kind of upgrade the dependent library to the newest version, the version that adds this method, and recompile them, and then everything should be fine, right? Sometimes this can become a lot of work. Imagine maybe with one mini app, it's fine, two mini apps, okay, but with a bunch of different mini apps and with different release schedules and so on and so forth, this can become a nightmare. So the second option is to try to make the change backward compatible. So how can we do that? So essentially, if you back up and think about it, essentially all we want to do really is say, we want some kind of way to say, hey, can I safely call this method or not, right? Does this method actually, is this method actually implemented or not? Are they using the new version of the library or not, is the question we're trying to ask, right? And so, and the method that we have is just this function, right? This is just, we just need this provide push recipient that returns a push recipient or not. So what we can do is, we can take this exact same line and kind of copy paste it into a new interface. And we'll call this a marker interface, push recipient marker. This interface won't actually do anything, but it will mark the fact that we are using the actual new version of the library. And we don't actually let our mini app class implement this interface or anything, because the idea is eventually we're going to remove this class, this interface. But just having that, if I actually implement a push recipient, if I implement on the mini app side a push recipient, I just implement this interface as well. And if I conform to this interface, then I can safely call provide push recipient on message received without any problem. And as time goes on, I can use Kotlin's great deprecation feature and kind of mark it as a deprecation level error once I made sure everyone is updated to the new app, so that anytime someone tries to update to the new version of the library, the new version of the library, whenever someone updates, they need to make sure they remove, they no longer implement this interface. So they just remove the name from their mini app so that the mini app no longer implements it. So wrapping up, things that would have saved us a lot of time had we known before they asked us to build a super app. First is look for modularization opportunities. And I want to highlight the fact that sharing is a lot closer than you might imagine. So a lot of times we'd have these discussions and say, well, but things are a bit different, or why would the Captain app need things that the customer app is using, or and so on and so forth. But the world changes pretty quickly. So modularize, like it's never too early to modularize, as one of my coworkers would say. Also, I mean, part of the benefits of this is it helps lead us to writing cleaner code, and also gives us the ability to open source things in the future as well. Consider sharing a design library early on. The earlier you do this, the much easier it is. Because unfortunately, what happens otherwise is everyone talks to designers give them a set of colors. Everyone has their own colors named by their own name in the food app, and similar colors are there in the ride-hailing app. And then you need to combine these at some point, and it becomes very difficult. But having a shared design library upfront would make life so much easier. Think about how when dark theme was announced on Android, right? If you had a shared design library, this becomes actually much easier of a task, because you already know where the colors are, and instead of having to go through every single place and figure out what the right colors are, you can actually just say, what is the corresponding color for this in the light theme versus in the dark theme, and so on and so forth. And establish regular conversations with Android devs throughout the company. So especially if there are multiple Android teams, it's natural that everybody gets really busy in their set of work and what they're working on. And it becomes much easier to just keep, it requires effort to keep conversations going with the other Android devs in the company. And the thing is, everyone is doing like really interesting and really good work, and there are things that we can benefit from every one of the other teams that are working. And having these conversations can save us a lot of time. So it's worth investing this time to save ourselves a lot of time in the future as well. Kind of some of the things we're thinking about moving forward is continuing to improve performance, both of app launch and of the mini apps launch. What else should we move out to the platform? So now, for example, we're talking about the networking layer. Should we actually provide the OKHTTP builders to these platforms to use? And then how do we kind of keep app size tamed? And how do we deal with these resource conflicts that occur from time to time that we talked about previously? And finally, this shared design system and UI library is another one of the areas that we're working on right now. And even from a development perspective, how do we make it faster for the teams that are developing these mini apps to develop their mini apps? And how do we improve the testing story around it? So we're starting to think about, like, how do we actually make the SuperApp kind of do a sanity check on these mini apps to make sure that nothing is obviously crashing, for example. And as time goes on and we have more and more people and more teams and more mini apps and so on, how do we do large refactors when it no longer becomes possible to clone repositories 1, 2, 3 and make changes here, here, and here? How do we think about doing these large refactors in an easier way? And similarly, how do we enforce good programming practices? Should we set up a set of lint rules, or what are the kinds of things we should do, and so on and so forth? So you can imagine kind of some of the things that we're kind of thinking about moving forward. I'd like to close with a rhyme. We were asked to merge our apps so all are reachable in just a tap. We didn't have a lot of time, so here's a summary through a rhyme. Convert the apps into libraries, resolving and manifest ambiguities. Library dependencies can be a mess. Build order manifests make the pain less. Handling singletons was next in line. Casting to an application is no longer fine. The application may not be there, and so are dependencies we need to tame. After all was said and done, everything was great under the sun, well, except the storm brewing about, resource conflicts causing many a doubt. Once everything agreed to coexist, we could walk down our wish list. Start off with building an API in the KDocs, we try not to lie. Backwards compatibility we must do in order to save a day or two of updating mini apps one by one can be tedious and not quite fun. Work continues on platform turf with a focus on speed and perf, not to mention quality of code, which is a never-ending winding road. All of this is not to ignore critical features to our core, tokens, login, and identity too, the home screen developed by the crew. Work like this needs a single team. Combining our silos was always a dream, one that we're realizing day by day, improving the release process since our release in May. I hope smaller companies share AARs, design systems, and utility jars. Communication is an absolute must. That in action help build trust. That is all I have to say. Hope you enjoy the rest of your day. Thank you.
Wow, thank you. I was not expecting a rhyme. That was amazing. All right, cool. Thank you so much. So everybody, we'll be taking questions on Slack. The channel is day 1 and like 10 o'clock. So let me go ahead and read the first question. So I think you covered it very briefly, but maybe you can tell us a little bit more about testing. So Matt asked, what test strategy did you use when, okay, I can't pronounce this word, librarizing, I think. Each module/library will have their own tests, of course, if they're being built by separate teams, but where do integration testing for the whole project go, and who owns those?
Cool. Yeah, good question. We're trying to figure that out now even, but what we have so far is that we already had a set of integration tests for the ride-hailing app and for the food app and so on. And so these continue to run, but they run against their container kind of thing. Because in our view, we don't actually see the specific subclasses because we just depend on the top level app class. So we can't actually run the tests from the SuperApp repo in this case. But essentially what we have done inside the SuperApp is we've created a set, well, right now, to be honest, it's just one instrumentation test. And surprisingly, that one instrumentation test has saved us so many times, where we just make sure that the SuperApp home screen can load properly, initialization works properly, and any of the criticals, there are 1 or 2 smaller mini apps that have to actually initialize to render the home screen, that those actually initialize properly without causing any problems. So we've done that. And now we're actually thinking the next step that we're trying to do is just do a very, very simple smoke test where we just click on each one of these tiles, make sure that we don't crash and just come back. Just to kind of make sure that the new version of the library of ride-hailing doesn't break anything, or of food and so on. Right,
that makes sense. Yeah, testing. I mean, I am with you. I definitely have cases where I thought this test will always pass, and then it failed because Google Maps APK, it upgraded and then just crashed my app. So cool. All right, so there's one more question. Did the SuperApp retain or add deep link support for the previously separate apps. So it's about deep link.
Yes, so we did. And the way we did that is actually, so they weren't using a common prefix, if you will. So the ride-hailing app was Careem : / whereas the Now app, the food app, was I think was Now : / or Careem Food : / something like that. So they were different, and so we built our own kind of activity that would actually receive these intents and then kind of forward them to the proper place accordingly.
So you have an agent that's
yes.
just handle it. That makes sense. Great. Okay. Let me just read carefully, but I don't think I see any more questions except I'm spitting fire. But that's and then awesome rhyme, love the rhyme. So I think that was a very pleasant surprise. Everybody loved it. So thank you very much, and we'll be breaking for 14 minutes now until the next talk. All right then.
Thank you.
Bye for now.